Hello everyone, welcome to Magnetized Labs. Today we are going to discuss the design of USB isolator using ADuM4160 in KiCAD. This is how the final design will look like. I am going to explain how to design this board from the scratch, so stay tuned until the end. What is USB isolator? A USB isolator is a device that separates or isolates the electrical connection between a USB device and a USB host like a computer, while still allowing the data to pass through. In simple terms, it lets your USB device talk to your computer without them sharing the same electrical ground. This is the block diagram of the project. I have used ADuM4160, which is a USB isolator IC from analog devices. The host side, I have used USB Type-A male connector to directly interface with the laptop or PC. And the power supply from the USB Type-A male connector, which is from the host side, is directly connected to the isolated DC-DC converter, which is converting 5V to the isolated 5V, and it is giving to the peripheral side USB Type-A connector. USB communication lines from the host is directly connected to the ADuM4160, and the output of the USB communication lines are directly connected to the slave USB with power and signal lines. What is ADuM4160? It's a USB port isolator based on analog devices. It comes with combining the high-speed CMOS and monolithic air core transformer technology for the better isolation. It comes with two speed data rates. One is 1.5 MP per second, which is low speed, and the other one is 12 MP per second, which is full speed. It allows bidirectional communication. It has upstream short circuit protection, and it also has Class A compact ESD performance protection. We can go to the schematics now. This is a simple design. This is a USB Type-A male connector, which is host connector. I have used decoupling capacitor of 1 microfarad for the 5V line. I have used PN junction forward biased diode to prevent the power flow from the external peripheral to the computer. These two are the USB data communication lines, which is directly connected to the USB ADuM4160 isolator IC through 24 ohm series termination resistors. These resistors are used so that the impedance of the total USB communication line, including the internal circuitry, will comply to the USB impedance matching of 90 ohms. And then this output V bus 5V is directly connected to the isolated DC-DC converter through a switch. This switch is used for resetting the total USB isolator so that you don't need to plug out the USB isolator whenever you want to reset or something else. Just you need to toggle the switch and you can toggle it on whenever you need. This will provide the 5V isolated power, which is used to supply the peripheral end of the USB isolator IC. And then I have used an LED for the indication purpose. This isolated DC-DC converter will supply maximum current of 200 milliamps. I have used the necessary decoupling input and output capacitors. We'll go to the IC now. This is VBus 1. If you're using a 5V supply, you can directly connect the 5V to the VBus 1 pin. And then this is VDD1, voltage regulator output pin. I have used 0.1 microfarad decoupling capacitors and 1 microfarad decoupling capacitor for the input 5V. These two are the USB communication lines. And then this is PDEN, pull down enable. As per the datasheet recommendation, I am going to connect this to VDD1. This is speed select upstream buffer. For the full speed operation, we have to connect this to VDD1. Input ground, and this is output isolated ground. This is speed select downstream buffer. As per the datasheet recommendation, for the full speed operation, I am going to connect this to VDD2, which is voltage regulator output. These are all the USB data plus and data minus communication lines, which is isolated from the host side. This is pull up enable. As per the datasheet recommendation, I am going to connect this to VDD2 with decoupling capacitor. The isolated 5V output power is directly connected to the VBus 2 pin for the output side supply. This is USB Type-A female connector, which is at the peripheral side or the device side. The 5V output is directly connected to the VCC pin, which is isolated from the host. I have used ESD protection diodes at both input and output end, which is host and device end, for preventing the device from the ESD failures. That's about the schematic. We'll go to the PCB now. Yeah, this is USB Type-A host connector, and this is USB isolator ADuM4160. These is a decoupling capacitor for the input 5V, and then this is USB signal routing, which is 90 ohm impedance matched. Okay, so this is an impedance matched signal. We actually have to use a 4-layer stackup for the better reference layout. So the second layer and third layer, also the fourth layer, I have used as the USB ground, which is actually the reference to the USB differential routing. And then this is input EST diode for the protection of EST failures. And then this is the switch for toggling the USB isolator on and off. This is isolated 5V DC-DC converter, which is going to connect again to the output side of the USB isolator IC. And then this is the decoupling capacitor for the input side, and this is for the output side. And then these are all the 24 ohm series termination resistors for complying the USB standards for the impedance matched circuit. And then this is the USB type A female connector for connecting any other devices. This is the 3 default USB type A male connector, and this is output USB type A female connector, which is isolated USB output with power of 200 milliamps at 5V. This is isolated DC-DC converter, and this is ADuM4160 USB isolator IC, 24 ohm series termination resistors in the input and output side. And then this is EST protection diode at both input and output side, indication LED, and then the necessary decoupling capacitors. That's it. I have not placed any component at the backside for the simplest routing and the assembly. Benefits of using USB isolator: it will protect from the surges and ground loop elimination. Any noise, if it is there, it will reduce, and clean signal for the better communication. Applications of USB isolator: protecting computers in labs and industrial settings, especially in medical devices, DIY electronics and embedded systems, industrial automation, especially in measurement and data acquisition systems. If you have any doubt, feedback or comments, you can let me know in the comment section. We are very happy to help. If you find this video helpful, stay tuned at Magnetized Labs for more insightful videos. Thank you.